So, yes, good morning, good evening, everyone. Welcome to another session. So we are going to continue from where we stopped yesterday. So let's keep the momentum going. So we are still working with while loops. So let's see the example here. So the example here, we have a variable called prompt where we assign this value and this one because the value is lengthy. That's why we created a variable to store the string there. Here we concatenate this second string to the first one. And here we have another variable message, which has empty value. So here we have our while loop. Our while loop start here, then we have message. We're saying if message is not equals to quit, then we keep doing what is inside until this condition is false. So let's run this. So when we run, we are prompted to impute anything. So let's write hello everyone. This, then when we press enter, it asks again to enter other values. So let's write quit. Then when we write quit, so it ended here. So let's move to the second one. So you can use a plug. A plug is a variable that you use to maybe set a condition. Usually a flag is assigned true or false, which means it's a Boolean type in most cases. So Boolean types takes true or false. In some programming languages, it takes 1 or 0, it depends. So Boolean, in short, takes true or false. When we see 1, sometimes in some programming languages, it means the value is true. When it is 0, the value is false. So in complex programs, sometimes we write code, we can have a complex problem, but we start bit by bit until the program builds become large and complex. So it happens that in some complex program, many different events can cause the program to stop running. Yes, because you have many segments. So just like we can call it a system. We know that we usually say we are developing a system because the system has so many segments. It has this function, this function, this function, this class, this function, this class. They are working together as a system. So different events can cause the program to stop running just like that, making it difficult to test all the conditions in one while statement. So to simplify this, a variable called flag can be used to indicate whether the program is active or not active. So program runs while flag is true. You can see the program should run while this flag is true and stop when any event set the flag to false. So when the flag is true, then everything will go as smooth as possible. But whenever there is a segment in the code that sets or changes or override what is in the variable flag to false, then something can happen. So this approach allows for single while condition with all other tests neatly organized elsewhere in the program. So let's see this example. This one will explain better. So now we have a variable prompt as we use. Then we have a variable called active. So you see that the type of this variable is Boolean. So while active, meaning while this condition is true, while the variable inactive is true, then we do this. We ask user for an input, then we check. If the input is quit, then we just set active to false, meaning this condition will be false. So we are no longer need this while loop. That's the meaning. So this condition will keep, this while loop will keep running if the value inactive is true. When something happens and we set active to false, then the program halts, stop running. So let's see. So look at this. Now the program asks for input. So we can write anything like hello. So you see we have hello, it asks again. Ario Data Science Academy. See, we have this. Let's say NLP, BUK. So you will just keep asking question until we write quit. When we write quit, it will just quit. Now remember the spelling. So the spelling must be as this one. So if you use capital letter, it will not quit, because we know in Python is. Now, there is something, again, apart from plugin, a while loop, we can also use break. Break is a keyword. It has a sister called continue. So we are starting with break. So what break does, it allows you to break out of the loop when a certain condition is met. So this loop you see here, we can rewrite it like this. We have what we call, I think, talk about it. We have what we call forever loop, like this. So we have set of statement here. So whatever we have here, while this condition is true, this kind of loop is called forever loop. It will just keep running forever. That's why it's called forever. If you want to use it, I don't think that we don't have it in Python, but in some programming languages, we have this. This one is also forever loop. In Java, when you write this, you are writing forever loop. It will just keep running. So inside the code, in the statements, you can write break so that you can break out of the loop. So let's see this example so that maybe we'll understand it better. So as usual, we have the string here, then we have while true, which means we are creating forever loop. It will just keep asking. Then here we are getting input from the user. We are asking user to provide some input. Then here we test. If the input provided by the user is quit, then we just break out of the loop. We just break unconditionally. So if it's not quit, then we print what the user provided. So let's run and see. So here I've been asked to write a name of a city. So let me write Kano. So when I write Kano, I would love to go to Kano. So we have people from Kaduna, we have from Jigawa, we have students from Adamawa, I think. We have some from Kampala, Uganda, etc. We have some from Lagos, I think, from that southern part of Nigeria. So sorry for. So let's write quit. When we write quit, look at this. I'm writing quit. Look at our code here. So it will just, when we reach this condition, so this break keyword will just cause the loop, will cause the program to get out of the loop. So we'll just break out of the, that's why it's called break. So it should just break out from the loop. So let's write, so you see, unlike this example, here we've written BUK, I think, okay, yeah, no. Okay, let's see. This is what had happened here. So we have this variable active, which is set to true. Then we have while true here. While active, I think I miswritten this because we didn't, I think this, you can neglect this line, the first one. So we have while true because we didn't use this variable active. So while true, so here we are starting our forever loop. Then we ask the user to provide some input. Then we check if the input is equals to quit, then we just break. Look at how this arrow break out of the loop, because this part, this line is part of the loop here. All of this here to this is part of the loop. But when we use this break, if this condition is true, then this line will be executed. If the condition is false, it will just go and execute this line. But when it breaks, so it will just break out of the loop when this condition is true. So it will just break out of the loop and this line will not be executed. This line, that's why we use this cross to tell you that this line will not be executed because of this break. It will just stop there and break out of the loop. So that's why we have this exit loop. So it will just continue with the rest of the code. If we have other codes here, it will just continue executing the rest of your codes. So again, additionally, you can use break statement in any Python loop. So any Python loop, you can use break statement. For example, you could use break statement to quit for for loop that is working through a list or a dictionary. So if you have for loop, you can still use it. Just use it, but use it with condition. So you have to use condition. If this condition is met, then break out of the loop. So I think maybe we can write it. Let's say we have for I in maybe range, maybe 1 to 100. So we can say if I is equals to maybe 12, then maybe we break out of the loop. So else we print I. So you see this one. So can someone guess what will happen here? Can you unmute yourself and tell us what is happening here? What will be the output for this?
I think we are trying to traverse across 1 to 100. So if
Yes.
when I reaches 12, it is actually going to break.
So what will be the output then?
It is going to be 1 to 12 only.
Yes, very nice. But are you sure 12 is inclusive?
No, 12 is not
Sorry, 12 is
inclusive.
not inclusive. It will print 1 to
1 to
1 to
11.
11 because
Yes.
12 is actually a number that satisfies that if it is equal to 12, then it should break. Sorry.
Yeah, so as you can see here, yes, when it reaches this, it will not print the last. So let's print. So you see we have up to 11. Yes, thank you for answering this question. So another sister of break statement is continue. So key point here using continuous statement in loops. So we use as we use break in loop, we also use continue in loop as well. So we set a condition just like this one. Then if the condition is met, then it will just continue. So the continue statement allows you to skip the rest of the code in the current iteration. So you have, with looping, we have iteration. That's why the looping is called iteration. So it just allows us to skip some code. So like this one, we have a current number here, which we assign 0. Then we have while the current number is less than 10, then do this. So because the current number is 0, so this condition is met. This condition is true. So what it will just do is it will just go ahead and execute this line. And this line tells the computer to increment the current number by 1. Then here we check. If the current number modulus 2 is equals to 0, then continue. So continue with the current code. Otherwise, then print the value. So which means if literally or technically, this means if a given number is even, because we say we use modulus, a number modulus 2 equals to 0 to check whether that number is even. So if a number is even, then continue to the next, continue with your execution. Just keep going. Otherwise, if the number is the modulus, if the remainder is not 0, then do this. So what happens here is, if I can draw an arrow here, let me annotate. This. So if I can annotate, when this condition is true, so what we will just do, it will just continue with the current execution. It will just execute this line again. But if the condition is false, it will just go to this line. This line. It will execute this line. So this is how it works. So instead of breaking, if we use break, it will just break out of the loop. But here, when we use continue, it will just continue with the current execution of the code. So this is it. I hope we understand. So let's kill this.
Excuse, I have a question.
Yes.
So with this current code, sir, you said while current number is equal to is less than 10, then if current number modulo 2 is equal to 0, so that means the moment it satisfies only one condition, it is going to break. Is that what it means?
No, it will not break because it will just continue with the next iteration. Maybe this code will iterate 10 times because it will start from 0 to 9, which means 10 times. So it starts with 0. Then if the condition is met here, it will go to the 1. If the condition is false, it will print this line. You understand? Then
Yes,
it will
sir.
go number 3, third iteration. So if the condition is made here, it will just continue to the 4th iteration.
Okay. Okay.
Or it will just continue. Instead of breaking, it will just continue and skip the rest of the code. So
Thank you
here,
very much.
what it does is skipping this line. So maybe we have number of lines, so it will just skip. Instead of, when you write code, the code usually runs right to left, yes, top to bottom, yes. If we are
Yes,
using
sir.
procedural things, so here it will start maybe from line 1, then it will go to line 2, line 3, line 4. So in line 4, we have a condition here. So if this condition is made, so it will go to line 5, but it will not go to line 6, 7, 8, 9, 10 because the condition is saying skip the rest of the code. That's what continue does.
Okay. I understand. Thank you.
Yes. So how do we avoid infinite loops? That is looping forever. So sometimes infinite loops crash your program. If you write in PHP, try writing one of the infinite loops we've written, like in Python. If you want to write in Python, just write while, then write true. When you write true, then write anything here. Maybe you can use print. Maybe you can say print hello, for example. Write hello like this, or hello world, whatever. So when you run this, it will just keep printing forever. So this one is called infinite loop. It will never stop. To never stop. It can take hours running or crash the whole system. So how do we avoid that? So in other programming languages, if you are using Java, C#, C++, so you can use this for. Then you use this. Yeah, if you like, you can put bracket like this and leave it empty. If you like, if you are using C++, you can use C out and write anything, whatever. So like hello, like this. Then maybe you close it, then you put semicolon. So when you run this in C++ or C or C#, this code will run forever, forever. So how do we avoid running code forever so that our program will not crash? So every while loops need a way to stop running. So there should be a kind of base or condition. So it won't continue to run forever. For example, in these counting loops should count from 1 to 5. So let's see the example here. So we have this one. We create a variable, we declare the variable x, and we assign 1 to that variable. Then we say if this condition is true, then print x. So this line takes the control. Make sure that this loop will not run forever because we keep increasing x. We'll keep increasing x. So x start from 1, then we print it because the condition is true. Then this line will increment x by 1. Then x now becomes 2. Then we check the condition again. Is 2 less than 5? Less than or equals to 5 is true. Then it will print. Then until we reach 5. When we reach 5, is 5 less than or equals to 5 is true. Then we print. Then we reach 6. So is 6 less than or equals to 5 is false. So that's why 6 is not printed here. So what will happen if we have logical error? Logical error is a type of error whereby the program will run successfully, but you get unintended output. For example here, what will happen if we write minus here instead of writing plus here? Can anyone tell us the answer? What will
It will
happen?
Oh.
What will happen?
It will
The
continue
loop will
running.
continue
Yes,
running
it
Safely.
independently.
will continue running because this condition will never met because this
Yeah.
one will be less. So this condition will always be true. So that's why you have to be careful when working with loops. So, however, if we accidentally omit this line, so if we omit this line, if we didn't write anything here, so the loop will run forever again. So this is the control. So this loop runs forever. So when you write this loop by omitting that x plus plus or x plus equals to 1, then the loop will keep running forever and forever. So let's go to another thing. So using while loop with a list and dictionaries. So we can use while loops with a list and dictionary. So previously, we worked with one piece of user information at a time. So we just asked user to give us one information like his name, his age, or any message, receiving just input to respond to it in a loop. So to manage multiple users or piece of information or pieces of information, so we can have many information at a time, maybe we can ask the user to give us many things at a time or list of preferred things or favorite foods, whatever. We can use list and dictionary along with the while loops. So avoiding modifying a list inside loops. Yes. So you have to avoid modifying lists because it may lead to maybe a undesirable result. So as Python may struggle to keep track of changes, yes, the changes you made in the list. So you are advised to avoid modifying the loop. Maybe the loop can grow. Maybe you keep growing. It keeps growing until you have undesirable results. So combining while loops with lists and dictionaries allows you to collect, store, and organize large amount of input so that you can analyze it or make a report later in the program. So let's start with the first example. So the first example, we are moving items from one list to another. Let's say you are given numbers, maybe from 1 to 10, then you are asked to separate or to pick out or to filter even numbers from that list. So if you have numbers from 1 to 100, then you can pick 2, you pick 4, so you keep copying from that list. So this is a simple example here. So we have these unconfirmed users with 3 items. So in a list format, so we have this list. Then we have an empty list here because the list we have this bracket with nothing in between. So here we have while unconfirmed users. What does it mean? It means that if this list is not empty, that's the meaning here. We didn't say while this has items, because in some programming languages like Java, C#, you have some functions that you use along with arrays like empty or length. So here we are asking if while this list is not empty, then do this, all of these lines are under the loop. So the first line, line 8, says that we fourth the items. Remember when we use list, how we remove items from the list to make the list, to shrink the list. So here it will just fourth an item. It will just take an item from the list and put it in this list current user. So here we print the current user, then here we append to this empty list the current user. So we are just copying or moving items from the first list to the second list. So this one is very important. Maybe in real life, you can see many examples in this format. Maybe you are developing a banking application, so you can check maybe if certain users have some amount of money, then maybe you can copy them and create a list of them. Maybe it can happen that maybe you have a list of CGPA from a particular local government. Maybe your local government chairman wants to award scholarships to students. Maybe you can set you can create an empty list. Then you have list of all the CGPAs. Then if the CGPA met certain criteria, then you can just copy it and put it here. But here, we are not specifying, we are just copying. So it will just take, there is no condition because we just use POF. It will just take the last items and bring it out and put it in this. So let's go to the next example. The next example, removing all instances of a specific values from a list. So look at this. Here we have a list called pets. So we have list of pets here. Then here we print the pets. When we print, we will see this list. Then we write a condition while cat in pet. You remember, if we want to check if an item exists in a list, then we use the keyword in. So while this cat is in the list, then remove the cat. So let's run this. See? So you see, so the cat is in the list, then we remove it. These lines remove the cat. Remember the function remove item from a list. Then we print pet. So the first time, this is the original list here, where we have the cat. So remember, we have cats appears 3 times in the list. So we have it here, we have it here, we have it here. So for the first time, because it's aloof, it will remove this one, then next remove this one, then next remove this one. So here we have cats removed. So we can use for loop with a list. Then next example. Oh, before next example, is there any question? Okay, no question. So
Yeah, there
we
is
can
a question, sir. In the previous example,
this one.
no, before the cat example, yeah, this example,
Yes.
I am a bit confused. I thought we are traversing through unconfirmed users. Then later on, we can now append the user to the current users.
We are traversing, yes, unconfirmed users. So here we take the last item. We just remove the last item, which is what, Candace?
Yes.
Yes, with pop. It will just remove this item from the list. Then here it print the user, saying that verifying user, then it will just print the user, the name popped, that is Candace. Then here it will just append to it. Yeah, append to this list. It will just put Candace here in this list. Then it will go to the next, because here is the end line, the lines that ends our loop. Then it will come back to this. Is there any item in the list again? Yes, there is. Then please take the last item. Then it will take this bride.
I
Then,
understand.
yes, you understand, yes?
Thank you very much.
Yes. So filling a dictionary with user input. So sometimes we can fill a dictionary with user input, or we can write our code to fill it for ourselves. So here we start with an empty dictionary here. So when we want to declare an empty dictionary, this is how the syntax is. Just open a curly brace here and close it with nothing in between. Then here we have polling active, and we set it to true. Then here we have a condition. While polling active is true, because it is true, while polling active, so if you write it, it means that while this is true, do this. Then it will ask for what is your name. Then we have the response here, another question. Then here we create a dictionary here. So this is the name of the dictionary as we declared it here at the top, number 1. Then here we have a key. So the key here is the name provided by the user here. So this is the key and this is the value. Remember, dictionary is just a key value pairs. So here we associate this key with this value, all provided by the user. So next line, we have another input, which says, would you like to let another person respond? Yes or no. So if you write yes, then it will just keep going with this line to just come back again here. Otherwise, if you say no, it will set polling active to false, which means that we are stopping the loop from running. So let's run and see. Okay, when we are done with the loop, then we have this line, which will just print the result. So if you have many results, remember these responses.items. So we have is a function that we use with dictionary. We have dot keys, we have dot values, then we have dot items. So dot keys, it will return just the keys, just like this name. With dot values, it will just return the values just like the response. With items, it will just return the key and the value pair at a time or at a go. So now let's run this. So when we run this, now we have the first question. What is your name? My name is Ali. Then which mountain you want to, let's call it Dala. So you like another, then let me say yes. What's your name? Musa. Which mountain? Boronduse. No. So I provided two different items. So I was asked my names, then I write Ali, then which mountains or hill will you like to climb? Then I say Dala. Then here, my name is Musa. Which mountain would you like to climb? I said Goranduse. So this is how we use while loops with dictionaries. So in summary, we did a lot yesterday and today. We learned how to use input first. We say that input function is complementary to friend function. So it's as important as friend function. Friend function allows us to see the result, while input function allows us to, or allows users to impute the result, their data to the system. It allows users to impute data to the system. So we also learn how to work with both text and numerical input. So with text, we don't need to parse the input, but with numerical, we have to use the input function with int or plot. And using while loops keeps program running based on user needs. We also learn how to explore control flow using while loops techniques like active, flags, break, and continue statement. So we learn a lot. So let's just sneak to chapter 8 and continue with the function. So chapter 8 is about function. So in this, we will learn how to write functions, we will learn how to call function. So we will define a function. Everyone will learn how to define his own function. So when I say function here, we am referring to user-defined function, the function that you define by yourself, not the system-defined function like print, input, and many others that we use. So you recognize how function makes program easier to write because you use it, you reuse it, you reuse it. You can use it a number of times depending on the circumstances. So we are going to explore various ways to pass information to functions for processing because functions can accept some kind of data so that it can process. Like the input, we open the bracket and provide some information. Like print, we open it and provide some information to it. So all these are examples of functions that receives some values. Some functions do not receive any values. Like sort, it doesn't receive value, but sorted receives values. So we are going to also distinguish between functions that display information and those that process data and returns values, because not every function returns values. Some do not return. Some will just do what you ask or do the task and leave the rest to you, while others will do the task and return the result to you. And we will learn how to store function in separate files called modules to organize and manage program files effectively. So let's start with what function is. So this is how function looks like. First, we have this keyword def for definition. So we are defining a function here. So when you want to define a function, you start with this keyword def, then you provide the name of the function. So remember, the rule for naming variable applies to naming a function. Then you provide brackets here. Then you write colon at the end. So make sure that the name of your function is meaningful. So after that, you just press enter and indent and write whatever statement you have. You may make calculations, you can print, you can return something. So this one is just a simple function. It doesn't receive anything here, any data, and it doesn't return any data. So when you define your function, what next? This function will just stop here. It will just stop here. If you have some code, it will just execute. Maybe you have some code above it, then it will execute the code. When it reaches here, it will just skip this line and continue with the rest of the code here. It will not execute this. So when you have a function, the lines are skipped until you call the function. So when you have many codes above, it will just execute any code there, provided that it's not function. And when it reaches a function, it will just skip it and go outside the function and keep continue with the execution of the rest of the code. So like this one, when you write this program like this, we know that this is a comment. So the computer has nothing to do with this. It will just skip this one. So this one is a function. It will just skip this one. And the computer will start from here. Here is just a call to function. When you want to call, when you want to execute a function, you just call it by its name. For example, we have Muhammad here. When I say Muhammad, then you will just answer. Musa, you will just answer. Mary, you will answer. Blessing, you will answer. So you can have many functions in your program. Then any function you want to call, just call it by its name. So for example, here we have greet user. That's the name of the function. So when we call it greet user, it will just look at this line. We say number 1. So it will just come and execute this line. When it executes this line, it will just enter this. Then this one is just a comment. It will just skip this one. Then it will just go to the next line, which says print hello. Then it will execute this line. What is done with this one, the second, then it will go to the third. The third is just continue with the rest of the code. So the rest of the code is this one. This one. So whenever a function is called, if it returns value, it will just return value to the where it is called, then it will continue with the rest of the code. Because this one doesn't return anything, then it should just continue from the next line. We have the call into the function line, then we have the next line here. So this is how it works. So let's see this line. This is the function. So we have this keyword. Here we are telling the computer, hey computer, please define a function. I want to define a function. Then you write the name of the function. Then if the function does not receive anything, then you leave this empty. Then here you indent. Remember this colon is a must. Then we have all the statement inside the function. Then this is the call to the function. So if we neglected this line, if we didn't write this line, let's run the code and see what happens. You see there is no output. We just define a function. It will just there, but it will not be active until it's called. It is called. So when we call it, we can call it even outside. When we write greet user, when we run it, you see now we have the out. So when we call a function here in this line, the computer will run all of this, but it will not execute what is inside the function. So this line call the function. So it makes all of this active so that we will see the result. Then when this finish executing, then this line will be executed. So this line is outside the function. So when we run this is what we have. So what's the syntax, the general syntax of declaring a function in Python? So this is it. First, we have the keyword, telling the computer that we want to define a function. Then, second, we have a function name. Remember the naming convention. Then, third, we have parameters, or set of parameters. So you can have a single parameter, or you can have many. it depends, and it can be, it's optional depending on your function. Then inside your function, you have statement. You can have a single statement or many statements. That's called body in your body. So the body includes statements as well as return expression. So you can, a function can return void or some values. So let's see. So when we apply this syntax to this, here we have the keyword that tells the function, that tells Python we want to define a function. Then here is the function name. Then here, no parameters are supplied here. So we have empty parameters. Then this is the statement, but we don't have return. So the function is not returning anything. So let's, because we don't have an example here, a function that returns something. So let's define a function that returns something. Let's say we are creating a function that is called sum. We have number 1 and number 2. So this function accepts 2 numbers and return the sum of those numbers. So like this. So when we run this, meaning we define a function. So we can call this function whenever we like. So we can say print, for example, then we call the name of the function. What the name of the function is sum. Then we can supply some values like 3, 2, and 3. So we can also have some numbers. We can call it however times we like. So let's run this one. So you see, so the first one, okay, we didn't call sum inside. So we have sum. So when we run this, so this 2 will come here. Then this one will come here. Then this one will come here. This one will come here. So we get the sum. So this one is a function with parameters. So you can also have a function with no parameters and can also return value. For example, we can modify that function, this one, greet user, though it doesn't know the user. So let's call it greet user 2, or let's call it greet users. Then, because it doesn't know the user, then let's call it let's say hello user. Oh, because we are not printing, so let's say return hello user. So this will return value instead of printing. So when we run this and we call it get users, and remember when calling a function, we use this bracket. So now it greets us. So how do we pass information to a function like what we did here? We pass this information. How do we pass it? So this is how it works. When you want your function to accept some data so that it can further process the data, so you supply the parameters. So depending on the context, you just give the parameter of a set of parameters. So like this one, this function is set or is designed to greet user, but it doesn't know the user. So instead of just at the coordinate. So we supply parameters. So here, the caller of the function just gives the user to grid like this one. So this explains how it works. Look at this. So we have the function name, we have this. So when we define a function, so it will not be executed, we will not see the output until we call the function. So here we are calling the function. And because the function expects some data, so here we supply the data here. So when you supply this data, what happens is this data will be transferred to this variable. So it will be stored in this variable. So this variable will be used locally here, locally in the function. So when we look at this line, it says that we print hello, then the name, the username supplied by the user, then we set the first letter to capital. So let's run this one. This is the actual example. When we run it, this is what we have because we supply Jesse here, then we have it printed here. So if you supply any other name, let's say we have other names here. Let's call it Jerry Adams lesson. So you see, we have a single function, but we call it number of times here, 4 times. So the first line, this one, line 5, will transfer this name to this. Then this line will be executed and print this name. Then this one will also do it as well. It's called with its respective data. So any question before we proceed?
Yes, sir. I have a question.
Yes.
Hello, sir. Can you hear me?
Yes, what's the question?
Hello, sir. Can you hear me?
I can hear you
sir.
very well.
How many parameters can any function take?
You can supply as many as you need.
Okay, sir. I'm going to return a function. Can I
you can
leave the function without returning the value? Or
yes,
okay,
look at
you,
this
sir.
function. This function, we didn't return anything. Look at this one. This one didn't return anything because we didn't have the keyword return. You see it? No keyword return. So when you see the keyword return, it means that the function returns something. Yes.
Okay, sir. Thank you, sir.
James?
Yes, sir. Can you hear me, sir?
Yes, I can hear you very well.
All right. I want to ask if writing a function, can you put a function, can you write a function, can you call a function before you define the function? Like, can you put the function at the bottom side of the code, but you must have called it at the top of the code?
No, just like a variable. You can't use variable until you declare it. So like function, you can't call a function until you declare that function. But in some programming languages, you can do that. But in Python, it's not possible.
Okay.
But in compiled languages like C, I think you can do that.
So you must always define it at the top before calling it below.
Define it at the top, then you call it, because you say that your code runs top, right to left, top to bottom.
All right, thank you, sir.
Yes, compiler just run the code at once, then compile the code at once, but read it line by line, while this Python is not work that way. So you start line by line. So it can give you the output of the top codes, but when it reaches the line with an error, then it will tell you that there is this error. So you have to define the function always.
So I have a question.
Yes. What the
in creating a new function,
yes?
can we define a function that will accept user inputs?
Yes, like this one.
Yeah, but here you the return value you is directly. I just wanted to
use,
be like,
yeah, you can do that. You can do that. Yes, you can do that. You can do that. You can call it maybe accept input, then you use input function inside a function. So you can use function inside a function. Like this one is our function, but this one is another function, is system defined. It's not the function that we define by ourselves. We are just
yes.
using it. So you can use input here. You can get something from the user, maybe data. You can call it data. Then you use input and get some data from the user, just like this one. Whatever you want to do.
So, sir.
Yes.
Thank you.
I don't know if a person can, for example, write this function first before the print command. For example, can someone start with writing greet user with the names or statements before coming to the print command?
Yes.
Okay.
Yes. If I understand you well, can you repeat the question first?
I mean, can someone start writing the functions first before the print command? Or, for example, just like in this one, where you run the print command first before running the function that you want to appear on that username.
Like this one, we write the function. Look at the function here. We start with the function. And we don't have print command here. You understand? It is the function that print.
So what I mean is that, for example, here where you write greet user in bracket Jesse, greet user in bracket Jerry, and what have you. Can you, for example, start to write it first before running the print listing?
Okay, before, yeah, no. You have to define the function before you call it. You have to define the function first. You have to start with the definition of the function. Then you call it. Otherwise,
okay.
Let's say I want to create a function, just like this. Imagine that this one is in different cell. This one is also in different cell. So let's say, let me just create a function, just imaginary function. Let me just call, let me in. Let's say I want to create a function called let me in. I call it here. You see, because when I look at this, let me in is not defined because it doesn't know about this. So when we call this, we'll get an error. We definitely get an error, you see? So we can define a function later. We can define a function first. Then we do whatever we want to do. So let's move on. Argument and parameters. So these things are sometimes used interchangeably, but they are actually different terms. But when you read many blog posts or code, you will see that these are used interchangeably, especially by the beginners. So argument is different, while parameter is different. So what's the difference between the two? Looking at the code above, the variable username in the definition, greet user, this one, this variable username here is an example of parameter. So because it is only one variable, so we call it parameter. If we have set of parameters here, then we can call them parameters. So this one is parameter. While this one, when calling the function here, we supply argument here. So it's a piece of information the function needs to do its job. So for this function to do its job, it needs username because the function is just to print the username. So it needs the username here. If this is not supplied, it can't use this function. Then the value Jesse in greet this is an example of argument. So this one is an example of argument. So when calling a function, you supply arguments. When defining a function, you define parameters. So that's the meaning. So how do we pass argument? So because a function definition can have multiple parameters, as we said, we can have set of parameters. And each one can be of any type of any class. It can be string, it can be integer, it can be dictionary, it can be a list, it can be any data structure in Python. So a function call may need multiple arguments. So if you have multiple parameters, it means that you need multiple arguments. So you can pass argument to your function in number of ways. So first one is we can have what we call positional arguments, which means we have an order, like asking the user to provide his names. So we can have first name, middle name, and surname in this order. And we can have, maybe you can start with surname, then first name, then other names, depending. So depending on the circumstance. So in that case, if the order matter, we have positional arguments. Then we have another one called keyword arguments. So in that case, we call the function with the name of the parameters. So we have to know in advance the name of the names of the parameters. Then we have list and dictionaries of values. So let's look at all of these examples. Let's start with the first one, positional arguments. So here the first line define a function called describe pet, which has two parameters, animal type and pet name. So when calling this function expects you to call it with the animal type name, then the pet name. So here we are calling the function, and look at the data we supply. This is the animal type, while this is the pet name. So when we call this one, let's see the result. So we see this hamster this data will be stored in this variable animal type. So it's just like assigning this value to this and assigning this to this. So this is called positional argument. So this one is in first position, this one in second position. So because this one is in first position, so this one will come to the first position, then this one will come to the second position because this one is in the second position. So that's why when printing, this one is printed first, then this one will be printed second. So because when you define a function, yes?
I have a question, sir.
Yes.
So I don't know where does this Harry comes in?
Where this Harry is
Okay,
here.
okay, okay, sir. Okay, sir. I see it. I see it. Sorry, sir. I understand. I
Yes.
understand.
Yes.
Oh,
So function, we can just say function define once. Let's give it this this kind of motto. Define once, use multiple times. So when you define a function, just like the print function is defined once, but look at how we use print function. We use it here, we use it here, we've been using it. It's just a single print function that we've been using since the time we start using Python, starting from Hello World. We've been using function. It was defined once, but look at how we use it. So similar to your function, you can just define it once, but you can use it multiple times. Sometimes you will say that I want to print Hello World. Sometimes you say you can print anything, almost anything. You see how we print. We can't even count how many times we use print function. The same with this one. You can define your own function, but you can use it multiple times. You can call it. So when you write the name of a function with this bracket, this is called function call. So here is a function call. We are calling the function and we are transferring this data to this one to this. So when we run this is what we have. Line 6, transfer this data to it, and it print these two lines, line 3 and 4. Then this one, second call, also do the same to just transfer the data to this, to this. So that's why we have this output. Then when using positional arguments, the order matters. Yes, the order matters. Yes, order matters when using positional arguments, because when you interchange, look at the first one, we start with hamster, then Harry, but when we interchange it, what will be the output? Look at the output. My Harry's name is hamster. Instead of my hamster's name is Harry, because the order in positional argument matters. You see this output, my hamster's name is Harry, while here is different. My Harry's name is hamster. So the position of the parameter or parameters matter. So what if we don't need to care about the position? We just need to supply arguments however we like. So in that case, we can use what we call keyword arguments. But keyword arguments, you need to know the parameters in advance before you can use it. Yes. Thanks to some code IDEs that provide intelligence. So when you just point on the name, it will just give you a clue of the kind of parameters you have. So let's start with this keyword argument. A keyword argument is a name value pair. So we have a name of the variable, then we have a value pair. So when you are calling it, when you are calling the function, you have to supply the name of the parameter, then you give the value to it. So in that case, we have name value pair. So keyword argument free you from having to worry about correctly ordering your argument. So you don't need to be mindful of the order of your parameters. So with keyword argument, so you can just call the name of the parameter, then in your code, then supply the value. So look at this one. We have the same function name, but when calling it, look at what we have. We say that go and look for this variable and assign this. go and look for this parameter in our function and assign this. So you can interchange it and you will get the same result. So let's see. I think let me do this and see the output. Let's do this. So here we have two different function calls. So let me interchange this one. Let me call fetch name first, but so let's see the output for this one. So you see, I have, so the first call, this is the output. The second call, the output. So we change the ordering. Look at the ordering. So here we start with the animal type, but here we start with the pet name, but the output remains the same. So this is very important. So the order of the keyword doesn't matter because Python knows where each value should go. Yes. So this one and this one are the same. We already run this one. So you see we have the same output. So there's thing that you need to note. So you should always know that when you use keyword argument, be sure to use exact names. If you misspell the name, then you will get an error. So you have to know the parameters in advance. So I think this one is yesterday's. So sometimes you can leave some parameters optional. Maybe you can, or you give a default value. If the user did not supply anything, then it means that you have a default value. For example, let's say you are creating a package for mensuration, maybe like getting the area of cycles, maybe area of sector, area of many other things. So you can maybe define a function and give a default value for pi, for example, pi. You can say the default value is 3.142, for example. So you can do that. Sometimes maybe you are designing a program whereby you ask users to supply their names. Some users use 2 names, while others use 3, first name, surname, and other names, while some use first name and surname only. So you can just make the other names maybe you can use the other name to be killing this. You can use the other name to be optional, or you can give a default value which is empty. So how do we define default value? So to define a default value, here you define your function, then you have the first parameter, then in the last parameter, you define a default value. What does this mean? It means that when user decided not to supply this one, the second parameter or the second argument when calling the function, then this will be set to doc. So if this parameter is not supplied when calling the function, it means that this will assume doc as default value. So look at this. Here we are calling the function with Willy, but we didn't supply the animal type. So if we like, we can just put comma and write animal type dog, but here we didn't supply it. So it will just assume that the animal type is dog. So when we run this, this is what we have. So here I have a animal type, which is dog. So dog will be printed. I have a dog. Any question on this? No question. So equivalent function call. So we can have function call that are equivalent, just like this one. look at, we already define a function. So all of these calls, all of these are calls to function, because look at the name of the function here. Look at the opening bracket when calling a function. Then here is the data we use. So look at the first one. We didn't supply the second argument, but because the function has default value, so it will just work. Then second one, we are using keyword dispatch to call that function and supply this value. It will work even though there is no second argument. Then this one we supply the first one, the second one, this one, the same thing. So this one works the same way. So you see we have the same output. Then how do we avoid argument error? Sometimes you will get error with argument. Maybe you didn't supply it or whatever, like this one. Look at this. Let's run this one and see. When defining this function, we say that this function accepts two parameters. We define it with two parameters. So it expects the caller to provide two arguments. So, but here we are calling it with nothing. So let's run and see. You see now we have an error. It's type error. Facts, describe fact, missing two required positional argument. So it tells you that when calling the function, this call to this function means two positional arguments. So you have to put the arguments in it. It can be variable, it can be anything. Anything. Then here you can also write anything, any, for example. So when we run, we don't have any error because the function expects parameters, two parameters that were missing. That's why we were fronted with this type error, and this is the description of the error. So it tells us the name of the parameters. If you like, you can just copy and put it in it so that you can have the keyword for argument. So returning value, we say that some function returns value, as we saw. Here is a function that returns value. Here the function expects the first name and last name, then it will return a full name here. So when we run this, here we have Jimmy and Hendrix. So when we run this, so this is what we have, because here we call the function with these two arguments. Then the function will return using this keyword. It will return what is stored in this variable, and what is stored in this variable is this name with this F formatting. So it will just put the first name here, then put the last name here with some space in between. Then it will capitalize the names. Then it will return the name to the caller. So this is the line that call the function. Then the result of this will be stored in this musician. Then here we print what is in musician, which is this. Simple. Then we can also make an argument optional, and we know that in real life some data are optional. That's why when you go online, maybe to fill a particular form, you will see if the data is mandatory, you will see a red star on it. But if it is optional, then you will see it without any star. So to make your argument optional, so this is how to do it. So let's start with this, the first one. So this one, we have this positional argument. We have the first name, middle name, and last name, but we know in real life, some middle name and names are optional. So let's run this and see. So here we have all that we supply. So when we run this one will transfer to this one to this, and this one to this. Then later the function returns the full name in title case. Then here we print, we store it in musician. Then here we print it using print function. Then look at this one. Here we are setting middle name to be optional by supplying default value, which is empty. So even if we didn't supply middle name, then it will work. And remember, the default value always comes last. Always comes last in the arrangement of your parameters. So look at it. We accept the values here. Then here we check if the middle name. So if middle name has been set, if the caller of the function call with middle name, that's the meaning here. So we have this line. If the caller didn't call it with middle name, then we print this line. So as simple as ABC. So the caller didn't call the function with the middle name. So this line will be executed. So return a dictionary. How do we return a dictionary? So look at this function, build person. So we have this first name, we have last name. So here we have a dictionary here. So we have first, then we have first name. Here we have last as key. Then we have the value, corresponding value, last name here. So here we return a person dictionary. So the function will return dictionary. So the function can return a variable, can return string, can return list, can return any other, can return int, can return plot, can return tuple, can return dictionary. So here we are returning a dictionary. So here the caller supply Jimmy and Hendrix to this. So then here we create a dictionary using this first as key. Then Jimmy will be the value here. Then the last will be Hendrix. Then the key will be last. So when we call this, so we have a dictionary. You see, this is how the dictionary looks like. So you can easily extend this function to accept optional values like middle name and age and occupation. So if you like, so you can put as many parameters as you can. So like this one, so you can say age is none. So by default it's none. So here we have person, we have last name. So if age, if the user supply age, then you have it here. If not, then no problem. You can just return a person. So here you have only this key. So if the dictionary is returned here, it will just return with 2 keys. But if the user supply age, so we have age in it. So when we run this, this is what happens. So James, can you reserve your question? Let's finish this because we have to finish. So using a function with a while loop, so we can use a function together with a while loop. So here we define a function. We have these parameters. We have first name, we have last name, and here, this one, we use a formatting to have the first name and last name here. So we have them, then we combine them here and store in this variable full name. Then here we return the full name in title case. Then here we have a while loop. So here we have forever loop. Then here we print, tell me your name. Then here we ask the user to provide his first name. Here his last name. So he will keep asking the user to provide the username and first name and last name. Then later we do this. But remember, this loop will keep going. I'm not going to run it. Then we have this, because when you run this, it will keep running forever. Then here we have the same code with some changes here. So if the first name is Q, that means quit, then it will just break out of the loop. Or if the last name is quit, then it will just break out of the loop. So either of the two. If the first name is quit or last name is quit, it will just break out of the loop. So let's run this one. When we run this one, first name Falalu, then last name Ibrahim. So when we run this, it keeps action. So let me write quick Q. So now the program stop running, or we break out of the loop. So now let's see passing a list. We can also pass a list to a function. So look at this. We have this list, Anan, Tai, Magot. Then here we pass the list. So here this variable refers to this list because we store the list in the variable. So we call the function called greet users. So we have greet users here. You always define a function. Remember, we always define a function before using it. So we define it here to accept names here, set of names. That's why we use names, not name. So we have set of names inside it. Then when it accepts, then we use for loop to iterate through all the names in the variable names. So remember this. I know that you already know this. So here we just grab the name, hello, the name in it. Then here we print the name. So if you like, you can print directly, but here we assign the name in this variable, then we print it. So this is it. So you see the first name is here, title case, then we have the second name here, then we have the third name here. So it will just iterate through the names. Then modify list in a function. So you can modify list, but you have to be careful whenever you want to modify a list in a function, because the list can grow depending on the condition. So here we have this and we have this. So here we have the list, here we have empty list. So look at this, we have while unprinted designs. So while unprinted design has something in it, while this unprinted design is not empty, then do this. So it will just take the last element and put it in this empty list. So later it will just print what we have in the complete models here. So it will just keep moving items from this list to this list. That's the use of this. So this is what we have. So when we print the last one, this is what we have. So I think we can call it a day because we are about 50 minutes on top of the hour. So thank you for listening. I think can have 1 or 2 questions and leave. Any question? If no question, then we can call it a day. So we meet next week.
Hello, sir.
Yes, sir.
Thank you, sir. I just wanted to ask, when are you pushing off the changes so that we can fully?
Yes, I'm going to. I think you have it here. You have yesterday's lecture. I think today I'm going to. You already have it. I think since I think 2 days ago.
All right, sir. Thank you.
Okay, sir. Hello. My question is, I have difficulty in doing assignment. So please, can anyone guide me?
Yes, you will be guided. Go to the Telegram and you will be assigned with a mentor. So if you have any problem with your code, or assignment, you can just ask your mentor always.
Okay, sir. Thank you.
Yes. So, James, you still have question?
Yes, yes, sir. I have a question. So
Yes.
initially, when you wanted to set optional argument, you just put a
Parameter.
space. You put a space in between. You put a
No.
space string. You put a space string. Now, the second time you are trying to put an optional argument, you put a non-variable, a non-variable type. So why is that? Is it that we can use either none or we can use just an empty space inside of the optional attributes?
Yes, remember when I use none, I use if. Look at this. I think we use if. Look, we say if, which means if the user supply it. Otherwise, we can just neglect it. So you
Okay.
can use anyone. So if you like, you can use space. So if you like, you can use none.
Is the idea that whatever that returns false, it's optional. Is that the idea behind it?
Yes. If the user didn't supply it, it means that if we put none here, if the user did, meaning the user didn't supply it, so it's none.
All right,
So
thank you.
yes. So we can call it a day since no question.
Okay. A question. You spoke about the mentors. I've not been assigned one, though I filled up the Google form.
So you are not assigned a mentor?
Yes, I've not been assigned yet, though I signed up on the Google form.
Okay, you will be assigned sooner. Maybe you can raise the issue. You can contact Bala. Yes, I raise the issue to him or Dr. Shamsuddin.
Okay.
Yes, but I think appropriately you can contact Bala. So I think we can call it a day. See you next week. Goodbye.